Hi, welcome back to engineering drawing. This is your Dr. Vasu. In this video, we are going to see the projections of straight lines when the line is perpendicular to one plane. If you want to learn this and many other interesting topics, please do subscribe this channel. And if you like this lecture, please hit the like button. That will keep me motivated to do many such videos in the future. Now, let's see what this line is when it is perpendicular and the projections are. So let's take a line here, a straight line of 100 mm long, we call it as AB, is perpendicular to HP and 30 mm in front of VP. So its projection is given, the line is given, the position is, this distance is 30 mm and at least one of the end distance must be given, either this end or this end. One end point distance from horizontal plane will be given. So here it is 15 mm above HP. So let's say it's mentioned clearly, the point B. So that means this point is A, this is we call it as B. So the line is like this, A, B, this is 15 mm and this is 30 mm. If you see the front view of this line, its projection is obtained on the vertical plane and is perpendicular to the reference line. And its true length is visible because obviously when it is perpendicular to HP, automatically it will be parallel to VP. So the projection on VP will be the true length, 100 mm long. Now, the front view is marked as A dash, B dash. And when you see this in the top view, it appears like a point here. Both the ends A and B coincide and we get the top view of both A and B as a point, single point. And we call it as AB. And here if you observe, the point B is kept in brackets because when you see it from the top, the A is visible to the observer, whereas B is not visible, is away from the observer. So that's why B should be kept in brackets. Now let us see how to draw this on the drawing sheet. So let's take the reference line XY and draw a line perpendicular to this reference line of some length. On this, at a distance of 15 mm here, at point B is 15 mm above HP. So at a height of mark 15 mm here from this, and that means the point B starts here. B and A is above. So we draw a line of, we highlight a line of 100 mm long here and we call this point as a B dash and this as A dash. So this is the front view of the line. Now this of course the length of the line is marked as 100 mm. It is the true length of the line. Coming to the top view is obtained as a point and it is at a distance of 30 mm. And when you rotate this horizontal plane, it has come down to the below the reference line. So below the reference line at a distance of 30 mm, we mark a point here, right? 30 mm. Then this point is both A as well as B. And as we see that from the top, A only visible to the observer and B is hidden, is away from the observer. So B is kept in brackets. So these are the projections of the line when it is perpendicular to one plane. Automatically when it is perpendicular to either HP or VP, it will be automatically parallel to the other plane. Okay, here in this case it is parallel to VP. Now let's take another point, another line here, a straight line 100 mm long, perpendicular to HP. Again it is perpendicular to HP, 30 mm in front of VP, and one end B is in HP. Okay, the point earlier it is above the horizontal plane by some distance, but now it is in the horizontal plane itself, the point B, and A is away from it. And this distance is of course 30 mm. Now let's draw the projections of this. Point B is, when it is seen in the front view, the front view of point B is obtained on the reference line. So we can start a line here on the reference line and mark a length of 100 mm here. And this point will be B dash, the front view. This is the true length of the line, right? From A dash, B dash. This is the front view of the line AB. Coming to the top view, Again, the top view is a point because it is perpendicular to HP. When it is seen from the top, appears like a single point at a distance of 30 mm. So at 30 mm distance, we mark the top view, that is A as well as B. Now, another one, it's a 100 mm long line perpendicular to HP and is in VP. Now, earlier we have seen that line is in front of VP. Now the point is the entire line is in VP, vertical plane. Its one end A is 30 mm above HP. So the line is like this somewhat. So here it is perpendicular to horizontal plane and A is nearer to HP and 30 mm above HP. You see, point A is nearer to, and this distance is 30 mm above horizontal plane. Now we want the projections. When you see the, let's generally draw the front view of this line. Whenever, in which view you get the true length of the line is drawn first. Here, in this case, the front view is, in the front view, we see the true length of the line. So we draw the front view of the line first. So draw the reference line and draw a line perpendicular to the reference line here. Mark this distance 30 mm first, right? 30 mm distance is marked, and this point now will be the A dash. This point will be A dash because A is nearer to HP. So this is A dash now and B is above. So now A dash B dash is 100 mm long. That is the true length of the line is visible in the front view. This 100 mm mark is marked here. Coming to the top view, when you see this line in the top view, the projection of this A as well as B, both will be projected on to the reference line. So the top view is on the reference line itself. So this point itself is the top view of both A and B. So here, if you observe, when you see it from the top, B is nearer to the observer and A is away from the observer and B is visible to the observer. So B is kept here like this and A in brackets because it is away from the observer and is not visible. But it coincides. Both A and B are both here only. But it is not visible. That's why it is kept in brackets. Now, let's take another line here. 100 mm long perpendicular to HP, right? And is in VP. Its one end B is in HP. So it is like this. B is in HP now. B is in HP and it is perpendicular to HP. Line is perpendicular. Entire line is in VP. So which view you draw first? Yes, the front view is drawn first because the true length is visible in the front view. Draw the reference line, draw a perpendicular and mark a distance of 100 mm because 100 mm long line is seen in the front view. So this 100 mm line is highlighted and marked as B dash here and A dash here. A is above and B is in the HP, horizontal plane. So B dash is on the reference line. Mark the length of this line, the true length. And coming to the top view, this point, the entire, both the points appear on the reference line only. So this point here itself is the A as well as B. B is kept in brackets because it is not visible to the observer when seen from the top. Okay. So another line, 100 mm long perpendicular to VP. It is now perpendicular to the vertical plane. Its one end is 30 mm above HP. So one end perpendicular to VP means automatically it is parallel to HP. That is first point. Second, one end is 30 mm above HP means automatically the second end also will be 30 mm above HP only. Okay. And it is 15 mm in front of VP. It is mentioned as one end 30 mm above HP. So this point is, say you take B, it is 30 mm above horizontal plane and 15 mm in front of VP. This distance is 15 and this is 30. Now what do you draw first? Either the front view or the top view. Which view you are seeing the true length of the line is to be identified first. So here in the top view, we see the true length of the line. So we should start drawing the top view. Now let us see. So draw the reference line and now draw a line perpendicular to the reference line, because on this perpendicular line only we have the projection of this line in the top view. So mark the 15 mm in front of VP, the distance. This distance is seen here in the top view. So from here, mark a distance of 15 mm from the reference line. From here, this point will be B, and from here you have the line, right? So draw a 100 mm long line, highlight it, and mark this as 100 mm, the true length of the line, and mark this as A and this as B. Okay, B is nearer to the vertical plane. A is nearer to the observer. When you see it in this direction, front view, A is nearer to the observer. Okay, now it is 30 mm above HP, because when you see it from in the front view, the height of this line, entire line above the horizontal plane, that is 30 mm is visible in the front view. And both appear to be a point here on the vertical plane. So at a height of 30 mm, you mark a point here, and this point will be the front view of both A and B, that is A dash and B dash both. And coming to the visibility, the point A is, when you are looking in this direction, point A is visible. So A is kept normally, that is front view, and B is away from the observer, that's why it is kept in brackets. So A dash and B dash in brackets. So these are the projections of the line when it is perpendicular to VP. Automatically it is parallel to HP. Okay, now another one. Suppose I reverse these points. Okay, earlier we have taken this A, B, and the projections are like this. A is nearer to the observer and B nearer to the vertical plane. Projections are obtained like this. Suppose if I interchange these points, okay, now I have taken this as A and this as B. What happens? The position of the point is not changed, so the projections of the line will not be changing, only the names will change. In this direction, in the front view, the point B is nearer to the observer, so this is the point B and this is the point A, nearer to the vertical plane. Coming to the front view, B is nearer to the observer in this direction, so B should be kept outside and A within brackets in the front view. So that's why this is the front view, B dash, A dash. So like this, we draw the projections of the line when it is perpendicular, and here actually the name of the points, a line name is not given, A, B or C, D, something like that. In that case, you can take at your convenience whether this point is A or B. It is up to you because it is not mentioned. Okay, now 100 mm long line perpendicular to VP. Again, one end B is in VP. Yes, it is in VP. The point B is taken in the vertical plane itself and 25 mm above HP. This height is 25. This height above the horizontal plane, this is 25, and this point B is in the vertical plane itself. Other A, and A is in front of VP, because in this particular case, the name of the line is given and the reference of the points also are clearly mentioned. So we have to draw clearly like this only. Now A is in front of VP. Now let's draw the projections. Reference line. And what do you draw first? The top view, because in the top view we see the true length of the line. From the reference line, because the point B is in the vertical plane, when you see it from the top, B is in the reference line. From the reference line, you draw a line here of 100 mm long. From here, 100 mm long, mark it on the perpendicular line. So this point will be B, right? And this point will be A. This is B and this is A. So this is a 100 mm long line. Coming to the front view, this point B is given as 25 mm above HP. This distance is given as 25 mm. So from here, mark a point of at a height of 25 mm like this, and this point will be the front view of both A as well as B. But is outside and B should be kept in brackets because B is not visible to the observer. Okay. Now, let's take another point, another line, 100 mm long, perpendicular to VP and is in HP. Now it is in HP, horizontal plane. And its one end B is 40 mm in front of VP. Point B, the entire line is in HP, right? And perpendicular to VP. This point is 40 mm in front of this distance is 40 mm. So we have to draw the top view only first because the true length is visible from the top. That is A, B. Let's draw the projector, a reference line and a perpendicular line here. And at a distance of 40 mm from the reference line here, we have to mark the point and this is 40 mm. From here, you have the line, right? 100 mm long line. So from here, you draw a line of 100 mm long here and this is 100. Now, this is the point A is nearer to the observer. So A and B here. Coming to the front view, can you guess where it is? In the front view, because the line, the entire line is lying on the horizontal plane, its front view lies on the reference line here. So on the reference line, we get the front view of A as well as B. But A is visible, B is away from the observer and is invisible. So B dash is kept in brackets. So these are the projections of the line when it is perpendicular to VP and is in HP. Let's see another problem. 100 mm long line, perpendicular to VP and is in HP. And its one end is in VP. So here, one end A is taken here because the point end is not mentioned, either A or B. So here we have taken a point A in the vertical plane and AB is in HP and perpendicular to VP. True length is given 100 mm. Now let's draw the projections by taking the top view first, right? Reference line, perpendicular line. From the reference line, we have to draw this because point A is in the reference line. From the reference line, you draw the perpendicular line and 100 mm mark here. 100 mm. This point is A here and this is B, right? B is in front of VP. So this is A and this is B, 100 mm long. Coming to the front view, yes, both the projections of both the points are on the reference line only, and you see it in the front view. So B is nearer to the observer. So B is kept outside and A is away. When you are looking in this direction, A is away from the observer. So A is kept in the brackets. So like this, whatever may be the position of the line when it is perpendicular to one plane and of course parallel to the other plane, the projections are drawn like this. So in the next video, we are going to see when it is inclined to one plane. Hope you had understood this topic very well. And if you have any questions or any suggestions, please do comment, do subscribe the channel and get alerts. Thank you.